What I want to do is introduce you to some things that are new for us in engineering ethics. Engineering ethics used to be about the fundamental canons of engineering and the professional codes of engineering, and typically these are written as the don'ts and do's of engineering ethics. And there's still interesting situations to explore where sometimes these codes, these prohibitions, or these exhortations are in conflict with one another, and engineers have to use judgment to sort out whether they should be making truthful statements or hold paramount public safety. Typically, engineering ethics has been about this kind of case. This is the Citicorp Tower in Manhattan, which was discovered in the 1970s to be deficient in its bolted connections. The connections were supposed to be welded, they were bolted, and so now the Citicorp Tower would blow over in a strong wind. And this is what engineering ethics is usually about, preventing a disaster. So through our ethical behavior, by conforming to the codes of behavior, we prevent disasters. And we use this case study in my classes because there's some interesting nuances in it to explore the fundamental canons and do the traditional job of teaching engineering ethics. But this idea of what constitutes a disaster is changing. Earlier this year, I was flying into Washington, D.C., and I was going to this National Council on Science and the Environment panel, and the weather was, not too bad. It was an inch of snow, the flight was on time, and I took the metro to my hotel. I walked to the conference site, and everybody had a story about the 5-hour ordeal that they underwent the previous day trying to get home or trying to get across the city. And somebody sent me this screenshot of Google Maps. This was January 21, 2016, and this is what an inch of snow evidently does to the Washington, D.C. metro area. Everything is like a parking lot. And so they all had these horror stories. It used to be that a disaster was somebody bolted rather than welted their structural steel connections and the whole building's going to fall over. Now, a disaster is an inch of snow. And this isn't supposed to be a disaster. So some of the people are saying, well, Washington doesn't get a lot of snow, and the first snowstorm of every single year was always kind of a surprise, and they don't have the plows and the salt and whatever the heck else. They just weren't ready, and people weren't prepared, and I'd say, well, that's unusual. It's not like we've ever had this phenomenon before. This is Atlanta, 2 years earlier, 3 inches of snow, and the exact same thing. This snowstorm came in somewhere around the afternoon, and everybody saw it coming in the morning, and they said, you know what I should do? I should leave early for work. Everyone in Atlanta said they would leave early for work in order to beat the storm. And when everyone in Atlanta decides to leave for work and get home at the exact same time, both the north and the southbound directions of the interstate are jam-packed. It only takes one accident to bring the entire metro area to gridlock. Now, this is a different idea of disaster. And it's not a disaster because somebody lied or cheated or stole or violated one of these fundamental canons. It's a disaster because we have insufficient capacity to adapt to things that were either surprising or we just weren't ready for. This is the new wrinkle in engineering ethics education that I want to bring to you, and it turns out that it's everywhere. This was the first notorious flash crash. This is 6 years ago, and if you weren't around to remember it, there were blue chip stocks in the Dow Industrials trading for a quarter at the time at this nadir. Because the automated trading programs had taken over the stock market and they'd gotten out of control, they created a massive plunge in the Dow Industrial average, but it only lasted for a few seconds. They traced the source of this flash crash back to a 35-year-old day trader in the United Kingdom. He was an Indian immigrant, and he posted an algorithm, and this algorithm was automatically posting trades. And in the aftermath of this investigation, the regulators said, don't worry, it's a very unusual situation. They did the usual kind of ethics investigation to find the bad actor, the bad apple that spoils the entire battle. And they said, we found him, and we're going to prosecute him, and it will never happen again. Except the rate of flash crashes has been increasing, not decreasing, as the system in which these traders work is becoming increasingly complicated. It's not the work of one individual, it's the entire system moving towards an inability to respond to unexpected perturbations. So the idea of what constitutes a disaster is different than it used to be. And it's not just different because the systems are more complex, it's different because the context in which they're embedded is more complex. This is 2 years ago in Phoenix. If you were here, you probably remember this event. Is this familiar to you? If you've been around for a couple of years, you were on the receiving end of an email from our provost at the time that we got this rainstorm. People wanted to know, our class is canceled. Now, Tempe in particular is sort of a residential campus and sort of not a residential campus. The faculty commute, many of the students commute, there's lots of graduate students who live off campus, and the provost said, campus is open, unless it's not. Please don't, penalize students if they couldn't make it to class. If you can't make it to class, don't have class, but if you can't make it to class, do have class. We had no institutional response to a storm of this magnitude. Why is that? Well, I went and I looked at the NOAA depth duration frequency curves that say, how often would we expect a storm that has over 5 inches of rain in Phoenix, Arizona? Plotted the rainfall event against the depth duration frequency curves and discovered that this storm is about a 2,000-year return period. In other words, we wouldn't expect a storm like this to come except once every 2,000 years, and evidently the Old Testament is the only record we have of storms like that. This is the forecast for southern Arizona a week later, and it's the exact same storm system, and it's the exact same precipitation forecast, so why are we getting the 2,000-year storm twice in 1 week? These are two kinds of contexts that we're not prepared for. The increasing complexity that cannot trace a disaster or a failure down to a single root cause, like a bad actor, and the changing context in which our engineering systems are embedded. So I did a lot of reading. And the reading led me to these critiques of the way we understand engineering and failure right now, which is dominated by risk. We recognize that risk isn't working for us the way that it used to. So the executive branch, this is a presidential policy directive, it's 21, and it's coming from 2013. The executive branch says what we really need is to make our infrastructure more resilient. We now know that we cannot prevent failures. Simply good engineering, simply ethical engineering is insufficient to prevent the kind of disasters that I've shown you so far. So what we say we need is a new approach, a resilient approach, that will recover from those disasters more quickly. So we had a workshop in Washington, D.C. This is a friend of mine, Steve Flynn, who's at Northeastern. He's a professor of political science. And Steve and several others of us, Dave Alderson, Dave Woods, Susan Clark, who was on my title slide and has contributed to this presentation, but isn't here with us in the room now, which is partly why we're videotaping. We got together and we said, what are the obstacles? And this is the way Steve presents it. We don't know how poorly prepared we are. We don't know how to respond, to create the resilience that we've been ordered by the executive branch to create. Even if we knew how to create it, we don't have the incentives to do it. And even if we had the incentives, there would be organizational and governance barriers in the way. So this is the way Steve describes it, and each one of us describes it in a similar way, but slightly different. What happened to me in the NSF when I heard Steve do it is I realized that each one of these maps onto a model of moral maturity that I like to use in some of my classes. It's published by Sean Hanna when he was at West Point Academy, and it says the first step to moral maturity is awareness. If you're not aware of a moral or ethical problem, then you certainly aren't going to be able to take action. After awareness comes judgment. You have to be able to formulate and rank order alternatives that would address the problem. After judgment, well, you might have the judgment but not be motivated to act. This is the classic schism between a cognitive understanding of the right thing to do and actually doing something. Writing a paper about it or getting the right answer on a test is different than behaving in a moral way. To actually get to what Sean Hanna calls moral conation, you must be motivated, you must cross this courage barrier, and then finally you can act. If these are the 4 obstacles to making infrastructure more resilient, and these obstacles map right onto Sean Hanna's model of moral maturity, then resilience is a moral problem. So let's look into one of these obstacles, lack of awareness. We don't really know what resilience is. Resilience is a buzzword that exists in several different disciplines, and David Alexander at the University College London was kind enough to do an etymological analysis. What I did was superimpose these colored ellipses to show the different disciplines through which the word resilience has moved. And right now, if the social sciences, let's say child psychology, learn something fundamental about what resilience is, supply chain management will not be informed in the least, because these disciplines are disconnected from one another. We have no fundamental theory of resilience, but we have lots of different approaches. And one of the ways that we organize the approaches now, especially those disciplinary approaches, was given to me by a PhD student of mine, Johnny Thomas, who's using the integral map to sort out resilience literature. The integral map looks at pronouns and the way we refer to things in the world. In the upper left-hand corner, we could see resilience at the scale of the individual and their experience, the scale of the child, the scale of the victim, the scale, well, our own scale. There's a lot of literature about grit, which I find frustrating, but grit works at the scale of the individual. Alternatively, we could look at the scale of the organization, the resilience of the community, or the resilience of the business enterprise. Terrific, we can do the same thing for non-human components of resilience. We could look at the its, the pumps, and the windows, and the buildings that are subcomponents of larger systems. Or we could look at the interaction between those systems. So we have the singular and the plural. We have the human and we have the non-human. I don't want to say static because there are dynamic elements of this, but the non-living and even biological but outside the human experience elements of resilience. And we can organize all of the literature in resilience this way. When we take just the most popular pieces, we find that the most highly cited papers that use resilience or resiliency in the title are in these three quadrants of the individual, the component, and the system, without papers showing up in the organizational. So this is a gap in at least the highly cited papers that Margaret and I are working on filling in. Let's keep going through awareness. We're now talking about judgment. The National Academies published this committee report from the National Research Council on disaster resilience, and it comes with lots of recommendations. Remember, judgment is the ability to formulate alternatives and rank order them from most to least preferred. And so here are the recommendations that are in this report. But the difficulty with these recommendations is that they all refer to risk. So here, our lack of awareness of what resilience is means that we lapse into these more familiar recommendations about the old risk paradigm, which is exactly what has failed us. So we lack the judgment because we don't know what resilience is, and in particular, resilience is difficult to measure, and that makes it difficult to rank order the alternatives even when we come up with them, whereas risk has been objectified to the point where we have quantitative models. Let's keep going on that measurement. This is from a paper that we published in 2010 before the executive order, but there are lots of different ways to think about measurement. The usual crisis cycle is on the horizontal axis. There's an event, we respond to the event, there's a longer period of recovery, and that recovery in response to the initial crisis may be accompanied by an even long-term restoration of whatever the damage was. When we think about measuring resilience, we can also disaggregate this kind of event in the vertical axis. We need resources. Those resources are utilized within processes, and those processes lead to endpoints. If our resilience measures are only the endpoints, then it's too late to see whether we have the resources on hand or effective processes to apply them and achieve those endpoints. But people think about resilience in all three dimensions. Sometimes you're having a conversation, and resilience is things. It's the diesel generators, and it's the oil containment boom that you have in reserve. Sometimes, though, resilience is in the verbs, the processes, the ways that you adapt. And sometimes resilience is in the outcomes. So if we're going to take a resilience approach to developing judgment, we need to have this pluralistic understanding of where to look for measures. And in particular, the verbs are the most difficult ones to measure. All right, so what are those processes? What are those verbs that need to be measured? Again, we published this in 2013, and there are at least these four. I'm going to go over them quickly so that we can get to an example. But they are sensing, anticipation, adaptation, and learning. These are all things that take place continuously, simultaneously. So I don't know that they come in any particular order or that they can go on in all orders, but these four at least are essential to a resilience approach to hazards. Terrific. Well, we also need to mention incentives. At the same time that Phoenix was underwater, California was, and in many ways still is, experiencing the worst drought ever. This is evidently what drought looks like in Los Angeles. These are the bursting water pipes underneath the streets of Los Angeles on the same day that they instituted strict lawn watering bans, which was July 30th in 2014. This 30-inch main next to the UCLA campus ruptured and leaked for 24 hours. It flooded out the basketball court at the UCLA Bruins, home center, and that evidently is a cultural disaster, and people demanded action. This is Hollywood just a month later, and this another month later, another area of Los Angeles where there was another serious. Evidently, if you want to wash your car, that's prohibited. But you may take a sponge and a bucket of soap down to one of these water main breaks once a month and lather up in the spill that resulted from the broken water distribution. People were outraged that the water distribution system isn't working, and we began to see pictures like this that exemplify the futility of keeping the aging infrastructure going. Why don't we have infrastructure in LA that works? Because nobody's invested in the infrastructure to keep it resilient. Lack of action. This is 1927, and this flood, which was documented in a wonderful book called Rising Tide, this flood changed the role of the federal government in the management of civil engineering infrastructure. It was such a national disaster that Congress passed several laws that empowered the Army Corps of Engineers to channelize, to levee, to dredge, and otherwise direct the flows of the Mississippi River to ensure that a flood like this would never happen again. How did that work out for us? This is 1993, and it is a flood of even more serious proportions. In 2011, the flood looked like this, and there was more water in the Mississippi River than at any other time. These are record in-stream flows, and yet we failed to see the same kind of damage. You can see some seepage that's pooling behind the levees, but the levees here are not breached, and the populated areas are protected. So what's the difference between 1927, 1993, and 2011? The difference here is the adaptive response. I've got a map of eastern Missouri, and this is an area, here's Cairo, Illinois, which Mark Twain wrote about. This is where the Ohio and the Mississippi River come together, and it's notorious for being subjected to floods. So in response to the 1927 floods, Congress created an area in eastern Missouri called the New Madrid Floodway. The New Madrid Floodway is an area that has flood easements. That is, it gives the federal government the right to inundate all of the properties in the floodway with flood waters purposely in order to spare the more populous areas that are along the banks of these rivers. But it had never been activated in 2011. Then in 2011, I forget the name of the general who was in charge of the Army Corps of Engineers, but that general held a press conference and said, this is the condition which Congress had in mind. We are going to activate the floodway. And how do you activate the floodway when you're in the Army Corps? You blow them up. You put dynamite in the levees, you detonate the dynamite, and you allow the water to pour in this northern location, and then later you got to blow up 2 levees in the southern locations to allow the water to flow back into the Mississippi. Naturally, the people who lived in the floodway, they sued. They're like, no, I know you have these easements on our deed, but the easement has not been activated in decades. It has never been activated, and therefore it has legally been abandoned. It took 2-3 days to sort these arguments out. And meantime, the waters are rising. So while the judge is deliberating, and the judge eventually found in favor of the federal government, saying this is the type of easement that you have to activate on a regular basis. These are 100 or longer year events. So the federal government still has the right. They moved all the families out, they flooded the New Madrid floodway, they spared the more populous areas, but the damage in the floodway was probably worse than it could have been if they'd activated the floodway sooner. So in a way, this is a positive case study, but this is exactly what reveals the new ethical problem for professional engineering. This is the trolley problem. This is the trolley problem with dynamite and the Mississippi River and millions of gallons of water. Should you direct the river through the floodway to damage just the 660 homes that are here where you have a legal right to do it? Or should you, the way we always did it, sandbag, build the levee higher, keep our fingers crossed, and let the levee break wherever it may? We can no longer say, as engineers, oh, not our fault, act of God, we did the best we could, I'm sorry that you got hurt. When we intentionally, adaptively, blow up our infrastructure to direct the damage to certain subcomponents of the system to keep the rest of the system going, now, who do we have to blame? Who has the courage to say, I've flooded out these people on purpose and this is my fault? Which is the hesitancy in the ethical psychology experiments when we do the experimental ethics. When we present people with the trolley problem, there's always a bias towards inaction, because with action comes responsibility. How the engineering community is going to respond to these responsibilities, that's what Susan Clark and I are trying to figure out. So Susan is looking at the National Infrastructure Protection Plan. She's saying, how do we decide what we protect and what we don't? This is from the Department of Homeland Security, and they've got criteria on their mind about what constitutes critical infrastructure. They've listed 16 different infrastructure sectors that are critical to US. How do they look? Just about the only thing I don't see is education. Which means if you have the choice between protecting, let's say, the workers at the chemical plant or the children at the elementary school, what are the critical infrastructure recommendations telling you to do? Which I find a little weird. On the other hand, 16 different critical sectors. What's that line from The Incredibles? When everyone is special, no one is. It doesn't tell you how to prioritize among these 16. It says they're all critical. And what we've learned from our changing understanding of disasters is that we don't have the resources to perform the way we thought we could. Something is going to break. So how do we decide when we can't protect everything, what needs to be protected and what doesn't? Susan has suggested the capabilities approach. The United States was founded at the apex of the Enlightenment. It was dedicated, particularly Jefferson, who wrote the Bill of Rights and founded a university, dedicated this idea of individual human rights. But how are those rights exercised? If you think, for example, about the First Amendment, we think of the First Amendment as freedom of the press. Have you heard it expressed this way? We often think of it as freedom of speech. But speech is insufficient. At the 18th century, the way you amplified your own voice, the way you had a larger impact, was you used the printing press, which was the dominant technology at the time. So the way you exercise your human right for freedom of speech is freedom of the press. Well, what would that be now? Evidently, freedom to tweet, freedom to post, freedom to what? Because the press is increasingly becoming obsolete. What Susan says is that it is this technological infrastructure that allows us to exercise our human rights in such a way that they become human capabilities. If we agreed that everyone has a right to a healthy life, but that healthy life requires medical care, what is the infrastructure that we provide them that allows them to exercise their human right into a capability? I think that this is a fascinating approach. We can refer to Martha Nussbaum, who is one of the advocates and the intellectual leaders behind the capabilities approach, and we can find all of the capabilities that Martha and others think are essential, but they're not prioritized. And remember, judgment is about being able to rank order our priorities. On the other hand, Abraham Maslow gives us a hierarchy, and even though this is now decades old and people say, oh, Maslow's obsolete, we've done so much other work, this is familiar to so many different audiences, including engineers, that we can say, look, it is possible to propose a rational hierarchy, a defensible hierarchy, in which things like food, water, and shelter, they come down at the bottom, and these are provided by infrastructure. Then a sense of belonging and community. After these basic needs are taken care of, these become important. Self-esteem, and I don't even know what self-actualization is. Somewhere in here, if you're familiar with Twitter, you have to put Wi-Fi, because Wi-Fi is evidently becoming one of those fundamental infrastructure. If you can't have freedom of what, you must have freedom of Wi-Fi. Our access to information fits into our sense of community, but also our sense of self-determination and esteem. So Maslow has the courage to give us a hierarchy. Nussbaum explains the capabilities that she thinks are essential. We ought to be able to prioritize the infrastructure that needs to be protected first versus those that we can sacrifice later. Now, I thought I'd take you through an example of extreme heat in Phoenix. And I'm not going to go through the whole example just in the interest of time, but I want to leave you with this frightening thought. Phoenix is getting warmer. As we get warmer, we need more power, electric power, for cooling. We also need more water, so we have increasing demands. But what does electric power use water for cooling, just like we need. So electric goes up, water goes up. And what happens to the electric power plants that provide this power? Their efficiency goes down, and the efficiency of the transmission wires goes down, and so does the risk of wildfires that would interfere with the transmission of electricity. So now we see in this complex systems diagram a possibility of a blackout during an extreme heat event in Phoenix, and that blackout could last several days. This is a different kind of disaster, a different kind of moral problem. It's not because somebody cut corners. It's not because somebody lied or was corrupt or was acting against the public interest. It's because the system is now so complex that there is no single root cause. In a complex system, cause and effect is a bit of a fallacy. You can only tease out these influences. And if we had a collapse of the power systems in the city of Phoenix during a 2-3 day extreme heat event, we'd be talking about thousands of casualties. It's even possible that we wouldn't be able to evacuate the city. Why wouldn't we be able to evacuate? Because the gas pumps all run on electricity. And the wildfires might be shutting off important evacuation routes. We just got this paper accepted at Climatic Change, and we can't believe we got away with the title. This could be the Katrina of extreme heat in the city of Phoenix. The question is, what are our responsibilities as engineers to address these kinds of new, complex ethical issues? That's what I want to sort of introduce to this audience, and that's what I want to get your feedback on. So I'm going to sit down so we can have kind of a conversation about it, if that's all right with you.